look around you right now. Like literally just look at the room you were sitting in. Feel the gravity anchoring you to your chair.
Right.
And notice the forward, irreversible march of the clock on your wall. We treat these things, space, matter, the arrow of time. We treat them as the ultimate, undeniable base reality.
Yeah, we assume we are sitting inside a closed, finite box called the universe.
Exactly.
Yeah.
And that everything that has ever happened or, will happen is just bouncing around inside that box.
Mm-hmm.
But what if none of that is fundamental?
What if it's all just a projection?
Yeah. What if every physical law we observe, from quantum mechanics to relativity, is essentially just the software rule set of a four-dimensional projection?
Continuously rendering from a timeless fifth-dimensional hard drive.
Right. A hard drive where time and distance do not even exist.
It is a proposition that demands we dismantle almost every foundational assumption we have about existence. I mean, if this framework holds, it forces a complete reevaluation of the Big Bang, the nature of black holes, the mystery of dark energy.
Pretty much the very fabric of how reality is woven together moment by moment.
Exactly.
That is the incredibly ambitious scope of the materials we are diving into today. Our sources come from H3OK Labs, authored by researcher Håkan Usak.
We are specifically analyzing his revision 19.0 and enhanced revision 18.0 documents.
Yeah, the ones that lay out what he calls a projection-based cosmological framework.
Huh.
But there is a secondary narrative here that is, well, I think it's just as fascinating as the physics itself.
Oh, the methodology.
Yeah, because the framework we are going to explore wasn't developed by, a solitary genius doing math on a chalkboard in an empty room.
No, it was forged through months of intense, iterative, and highly contentious debate.
Between a human researcher and an artificial intelligence.
The methodology is arguably as revolutionary as the cosmology itself, honestly.
Oh.
We are looking at a completely new way of doing theoretical physics.
Because the human provided the intuitive leaps and the radical ontological shifts, right?
Right, while the AI served as this untiring, rigorous logic engine, forcing the human to clarify literally every single hidden assumption.
And as always, I have a resident expert here to help guide us through the deep end of the pool. So, okay, let's unpack this. Before we try to tackle the fifth dimension, I want to look closely at this human-AI dynamic.
It's a great place to start.
Usak wrote a piece alongside his primary papers detailing his process, and it frames this collaboration in a way I just hadn't considered. Most people use AI as like a very fancy autocorrect.
Yeah, you write a rough email, you ask the machine to make it sound professional, and you hit send.
Exactly. But he describes reaching a point where that transactional relationship completely broke down.
It broke down because in theoretical physics, you just cannot separate the grammar from the science. He uses a phrase in his notes that is absolutely crucial to understand. He says, precision of language as precision of thought.
Precision of language as precision of thought.
Yeah, because when you are building a new ontological framework, like a completely new model for what reality actually is, every single word establishes a mathematical and logical relationship.
Give me an example of that. Like, how does a single word change the physics?
Well, think about the verbs creates versus instantiates.
Right.
If you say a process creates a particle, you are implying a temporal sequence, right? You are saying that at time A, the particle did not exist, and at time B, it did.
So you've fundamentally baked the assumption of linear time into your theory.
Precisely. But if you say it instantiates a particle, that feels entirely different.
That sounds like a computer program calling upon a pre-existing asset in a library and rendering it on screen.
Exactly. The asset always existed in the library. It's just being expressed locally.
Oh, wow. That is a massive distinction.
It is. And when Usak was using the AI to polish his early drafts, the AI kept trying to flatten his radical vocabulary back into standard physics terminology.
Because the AI was trained on standard physics.
Right. The model was trained on millions of pages of mainstream scientific literature, things like the Standard Model of Particle Physics and Lambda CDM cosmology. So, unconsciously, the AI's neural weights favored the orthodox worldview.
So it wasn't just autocorrecting his syntax.
No, it was trying to autocorrect his physics back to the mainstream consensus.
That implies the AI was almost acting like a conservative peer reviewer, resisting the paradigm shift. But he didn't view this as a failure of the AI, did he?
Not at all. He viewed it as a feature. Constructive disagreement.
Constructive disagreement. I love that.
He realized the AI was acting as an intellectual mirror. Because the AI kept misinterpreting his ideas and trying to force them into established scientific boxes, it forced Yusak to realize where his own definitions were too vague.
He couldn't rely on human intuition to paper over the cracks.
Exactly. The machine doesn't have intuition. It only has logic.
I read the part in the sources where the AI kept desperately searching for a central organizing principle. It kept asking him, essentially, okay, what is the single foundational concept here? Is it time? Is it gravity? Which concept is at the top of the pyramid?
Yeah, the AI really wanted a hierarchy.
And he had to fight the AI to explain that his theory wasn't a pyramid at all.
That goes straight back to the AI's training data. Almost all established physics theories are hierarchical. You have a foundational equation or a base field, and everything else is a subsidiary derivative property of that base.
But Usak's framework is fundamentally relational.
Yes, relational, not hierarchical.
I want to make sure I really grasp the difference between hierarchical and relational in this context, because if I build a skyscraper, that's hierarchical.
Absolutely. The foundation is at the bottom, the steel frame rests on the foundation, the floors rest on the frame.
So if I remove the top floor, the building still stands. But if I remove the foundation, the whole thing collapses. The foundation is privileged.
A relational framework, by contrast, operates more like a complex spiderweb or an ecological system. There is no bottom slab.
It's all connected.
Right. The tension between all the different threads is what creates the structure. If you remove the concept of the fifth dimension from his theory, the concept of quantum uncertainty loses its mechanism entirely.
And if you remove the projection codex, the fifth dimension has no way to interact with our reality.
Exactly. None of the concepts can exist in isolation. They mutually define one another.
So trying to explain this relational web to an AI that is hardwired to build skyscrapers must have been exhausting.
I'm sure it was. But it forced him to articulate the tension in every single thread. He says the AI slowly built a unique internal model of his specific conceptual architecture.
It learned how to argue within the rules of his universe.
Yes, which is incredible.
Think about that for a second. If you listening to this stopped treating AI as a vending machine that just dispenses answers and started using it as a tireless debate opponent to stress test your own worldviews.
Yeah.
I mean, that changes the entire utility of the technology.
It becomes a dialectic interface. And according to the author, this intense, sustained philosophical sparring allowed him to reach a level of internal theoretical coherence that would have been almost impossible for a single human mind.
Just because a human gets tired of checking thousands of cross-references for logical contradictions.
Exactly. But the machine does not get tired.
Okay, so let's take a look at the theory that survived this grueling gauntlet. The foundational concept in the H3OK Labs framework is what they call the monistic topology. And to really appreciate how wild this is, we have to look at what they're trying to overthrow.
Right. We have to talk about lambda CDM.
Yeah, you mentioned lambda CDM earlier. That's the current heavyweight champion of cosmology.
Right. Lambda CDM stands for lambda cold dark matter. It is the mathematical formulation of the Big Bang Standard Model. And the absolute bedrock assumption of lambda CDM, and frankly almost all modern physics, is that the universe is a closed system.
Meaning everything that exists is trapped inside a four-dimensional bubble of spacetime.
Correct. The closed manifold assumption means that all energy and all matter were present at the initial singularity.
So the universe might be expanding, but it is not receiving any new input from outside because in a closed system, there is no outside.
That's the consensus view, yes.
But the author argues that this closed system assumption is exactly why theoretical physics has been stuck in the mud for the last 40 years, right?
Yeah.
It's the reason we have had to invent invisible concepts like dark matter and dark energy, just to force our equations to match our telescope observations.
That is his core argument. The framework proposes a radical ontological shift. It says our universe is an open system.
An open system.
Yes. Our four-dimensional observable reality is actively, continuously coupled to a higher dimensional state. Specifically, a fifth-dimensional substrate.
Now, hold on. When anyone says fifth dimension, my brain immediately defaults to science fiction. I picture a tesseract, or like moving in a direction that is somehow perpendicular to up, down, left, right, forward, and backward.
Which is how pop culture usually portrays it, yeah.
But the papers are incredibly strict about how they define this, and it is not a new spatial direction.
No, it is absolutely crucial to strip away the sci-fi tropes here. The fifth dimension in this framework is a timeless, non-local state domain.
A state domain.
Right. It is not a place you can travel to in a spaceship. The concepts of distance, before and after, are strictly four-dimensional properties. In the 5D substrate, those concepts simply do not exist.
Okay, if distance doesn't exist, how do things relate to one another?
They exist in a state of perfect ontological coincidence. Everything is essentially superimposed upon everything else. It is an infinite reservoir of pure potential, which the framework refers to as S energy.
S energy. And there is a variant of this called S matter, right?
Yes, S matter is described as a non-baryonic form of this potential.
Baryonic matter being what you and I are made of, like protons, neutrons, electrons.
Right. S matter is fundamentally different. It doesn't interact with light or electromagnetism, but it projects gravitational curvature into our 4D world.
So it has gravity.
Yes.
Hmm.
The framework suggests that this 5D S matter scaffolding is what mainstream physicists are currently misidentifying as dark matter particles.
Okay, I can sort of conceptualize a timeless domain of pure energy, but why is it mathematically necessary? Like, why couldn't this reservoir of potential just exist in 3 dimensions at the very beginning of the Big Bang? Why force a 5th dimension into the math at all?
It's a great question, and the author provides a beautiful geometric argument for this called the tetrahedral limit, or the geometric proof of dimensionless origin.
Okay, the tetrahedral limit.
It directly attacks the standard Big Bang idea of a singularity. Standard cosmology claims that at time 0, all matter and energy in the universe were packed into a perfectly uniform, infinitely dense, equidistant point in 3D space.
Right, the classic singularity.
The framework asks us to look at the actual geometry of packing. If you take regular tetrahedrons, which are the simplest, most fundamental 3-dimensional volumetric shapes, basically 3-sided pyramids,
Yeah.
and you try to pack them together to fill a 3D space perfectly, you mathematically cannot do it.
Wait, they don't tile perfectly, like cubes do.
They do not. In 3D space, the absolute maximum packing fraction for regular tetrahedrons is roughly 0.8563.
So you can only fill about 85.6% of a given volume.
Exactly. The remaining 14.4% is inescapable geometric gaps. You cannot achieve a packing fraction of 1, which would mean perfect, gapeless coincidence.
Let me stop you there because I want to push back on this a bit.
Yeah.
The Big Bang singularity, by definition, has 0 volume.
Right.
It is a dimensionless point. So if there is no volume, why does it matter how 3D tetrahedrons pack together? You aren't packing them into a box, you're packing them into nothing.
That is exactly the question a skeptical physicist would ask, and it's a good one. But the issue isn't the singularity itself. The issue is the first infinitesimal step out of the singularity. To transition from a dimensionless point of infinite density into a 3-dimensional spatial manifold, the immediate subsequent state must geometrically tile. The energy has to map onto a geometry.
I see.
If the foundational 3D geometry inherently forbids perfect equidistant packing, if it immediately forces irregular gaps, then a perfectly smooth, uniform, zero-entropy origin state is mathematically impossible in 3 dimensions. The geometry corrupts the uniformity instantly.
I get it now. The transition from 0 volume to any volume at all is where the math breaks.
Exactly. To maintain a packing fraction of 1, to have an origin point of perfect ontological coincidence where distance is truly 0 and uniformity is absolute, you require a higher dimensional domain.
So the proof concludes that this state of perfect coincidence can only be resolved in a 5D topology.
Yes, that is the crux of the tetrahedral limit.
So we have this 5D substrate, perfectly packed, 0 distance, completely timeless. It is a reservoir of S energy. How does that static, timeless potential turn into the dynamic, sequential reality we live in?
The framework argues that our observable 4D spacetime is not something that was created once in a massive explosion billions of years ago.
Right.
It is a process that is actively, continuously being instantiated or projected from the 5D substrate. Reality is rendering right now.
I want to stretch an analogy here. Tell me if this works. Is the 5D substrate basically the code on a video game hard drive?
Okay, let's run with that.
Because on the hard drive, the final boss, the first level, the music, the physics engine, they all exist simultaneously as static code. There's no time or distance on the hard drive itself. The final level isn't physically farther away from the first level on the silicon disk.
That tracks perfectly.
But when you boot up the computer, the processor starts reading that code and projecting it onto your monitor. On the screen, suddenly there is sequential time. The character has to walk across a physical distance to reach a goal. A causal reality is rendered from the timeless potential of the code. So, is our 4D universe the screen?
That is a remarkably accurate way to conceptualize it. The 5D substrate is the hard drive, holding infinite superposed potential. Our 4D spacetime is the monitor. The computer's processor, actively reading the code and rendering the graphics frame by frame, is the ongoing process of cosmic instantiation.
The implication being that reality isn't a persistent physical object, it's an ongoing event.
An active process, yes.
But if we abandon the idea that the universe is a physical box, what happens to all the physics that actually works? Like GPS satellites rely on Einstein's general relativity. Microchips rely on quantum mechanics. If this framework upends our view of reality, does it just throw out a century of proven math?
No, and this is where the framework proves its sophistication, honestly. It doesn't attempt to rewrite the empirical math of standard physics. It introduces an ontological layer beneath it.
An ontological layer.
Right. General relativity remains completely intact as the geometric description of gravity on the 4D screen. The math works perfectly to describe how the rendered pixels behave.
So it doesn't break the game engine, it just explains where the code for the engine is stored.
Precisely. It argues that the curvature of spacetime we measure as gravity in 4D is actually the geometric shadow cast by S-matter structures residing in the 5D substrate. The equations of Einstein are the exact right mathematics to measure the shadow. The framework just wants physicists to admit it's a shadow, not the base object.
Okay, if 5D is the code and 4D is the screen, we are left with a massive mechanical problem. How does that raw, kindless potential actually become the sequential reality I'm experiencing? What is the translation mechanism? What is the processor in this analogy actually doing?
The processor operates according to what the framework calls the Projection Codex. If reality is a projection, there must be a strict set of structural rules dictating how 5D information is translated into 4D physics. Otherwise, it's just philosophical magic.
Right.
The codex provides the logical constraints for rendering.
Let's examine these rules, because this is where the theory actually claims to solve the biggest mysteries in science. Rule 1 is logical non-contradiction.
This is the baseline filter. It prevents mutually exclusive states from coexisting in our 4D spacetime. It guarantees internal consistency.
Because in the 5D substrate, infinite potentials exist simultaneously in superposition.
Yes, but the 4D screen cannot render paradoxes. You cannot have a particle located at coordinate x and simultaneously not located at coordinate x on the screen. The codex forces a resolution to maintain logical causality.
That makes total sense. A video game will literally crash if you try to render two contradictory physics states in the exact same pixel.
Exactly.
Then rule 2 is the minimal complexity path.
Right. Out of all the viable ways 5D potential could be projected into 4D, the codex always favors the configuration that minimizes global complexity. It is fundamentally an efficiency mandate.
Is this related to why water flows downhill or why light takes the fastest path?
Absolutely. It is the ontological root of the principle of least action in physics. Energy follows the path of least resistance because the projection engine inherently defaults to the lowest processing burden. This rule also explains why massive, simple cosmic structures form before highly complex, fine-grained structures like planets or biological life.
It's just more efficient to render. But rule 3 is where the heavy lifting starts, the finite resolution rule. The sources claim this rule beautifully demystifies all of quantum mechanics. How does a resolution limit explain the weirdness of the quantum realm? And we probably need to define that weirdness first.
Let's look at Heisenberg's uncertainty principle. In classical physics, if you have a baseball moving through the air, you can know exactly where it is and exactly how fast it's going at the same time.
Easy enough.
But in quantum mechanics, if you look at an electron, you cannot know both its exact position and its exact momentum simultaneously. The more precisely you measure where it is, the less you know about how fast it's moving, and vice versa.
And mainstream physics usually says this is because the universe is fundamentally blurry at the microscopic level, right? That randomness is just baked into the fabric of reality. Einstein famously hated this and said, God does not play dice.
And this framework agrees with Einstein. It argues that quantum uncertainty is not fundamental randomness. It is an artifact of a finite informational boundary.
Wait, explain that.
Think about the monitor in your video game analogy again. It is a finite resolution, a specific number of pixels. If you try to render a perfectly smooth diagonal line, the screen physically cannot do it. It has to render it as jagged staircase pixels.
Because it hits the hardware limit.
Yes. The finite resolution rule states that the 4D projection inherently possesses a finite informational bandwidth. When infinite 5D potential is squeezed through this 4D bottleneck, the projection simply does not have the processing capacity to render conjugate variables, like position and momentum, with infinite sharpness simultaneously.
Oh, I see where this is going. If the rendering engine spends all its processing bandwidth figuring out exactly how fast a particle is moving, its momentum, it literally has to lower the texture resolution of the particle's location to save bandwidth. The universe pixelates.
That is a highly accurate conceptual translation. The mathematical term used in standard physics is a Fourier transform limitation. In signal processing, a Fourier transform shows that a signal cannot be sharply localized in both time and frequency domains simultaneously.
So if you want a short, sharp pulse in time, you need a very broad, messy range of frequencies to build it.
Exactly. The framework argues that the uncertainty principle is exactly this kind of bandwidth limit between the 5D domain and the 4D projection.
That removes all the spooky magic from quantum mechanics. A superposition isn't a magical particle being in two places at once. It's simply an unprojected 5D potential waiting in the hard drive.
Yes.
And when you measure it, the codex forces a definitive projection onto the screen, governed by Rule 1, non-contradiction, and we call that collapsing the wave function.
It replaces magic with logical processing limits. But what happens if you push the processing engine too hard? What if you pack an overwhelming amount of mass and complexity into a tiny sector of the 4D screen?
You're talking about Rule 4, critical complexity reversion.
Yes. When a localized area of 4D spacetime exceeds a critical physical threshold, specifically extreme density surpassing what physicists call the Tolman-Oppenheimer-Volkoff limit, the projection fails.
We need to define that limit.
Yeah.
What exactly is the Tolman-Oppenheimer-Volkoff limit?
So when a massive star dies, gravity crushes its core inward. First, the electrons push back. That's called electron degeneracy pressure, which creates white dwarfs.
Oh.
If gravity is stronger than that, it crushes the electrons and protons together to make neutrons. The neutrons push back, neutron degeneracy pressure, creating a neutron star.
So with you.
But if the mass is so great that even the immense pressure of neutrons pushing against each other is overcome by gravity, that point of failure is the Tolman-Oppenheimer-Volkoff limit. In standard physics, gravity wins completely and the matter collapses infinitely into a singularity.
But the H3OK framework says singularities are impossible due to the tetrahedral limit. So what happens when the star crosses the TOV limit?
The codex enacts a critical complexity reversion. The informational density surpasses the rendering capacity of the 4D manifold, so the projection crashes locally. Sequential time stops, the 4D geometric laws cease to apply, and the information gracefully reverts back into the timeless 5D substrate.
And what do we call a localized area of extreme density where time stops and 4D physics breaks down?
We call it a black hole.
Wow. So a black hole is not a cosmic trash compactor crushing matter into an infinitely dense point. It's a resolution point. It's a buffer overflow error in the universe's rendering engine, and it acts as an exhaust valve, securely returning data back to the 5D hard drive.
Exactly. And this conceptual shift provides an elegant solution to the most agonizing crisis in theoretical physics, the black hole information paradox.
This is Stephen Hawking's famous paradox. Walk us through why black holes cause such a headache for physicists.
It comes down to a core tenet of quantum mechanics called unitarity. Unitarity essentially dictates that the sum of all probabilities in a quantum system must equal 1, or 100%.
I don't know.
Practically, this means that quantum information can never be fundamentally destroyed.
Like you can burn a book, but theoretically, if you track every piece of ash, every photon of heat, and every wisp of smoke, the information of the text still exists in the universe. It's just scrambled.
Okay, information is immortal. But in 1974, Stephen Hawking proved mathematically that black holes are not completely black. Because of quantum fluctuations near the event horizon, where pairs of virtual particles pop into existence and one falls in while the other escapes, black holes slowly leak energy. This is Hawking radiation.
So over unimaginable timescales, a black hole will completely evaporate into nothing.
Right. And if the black hole evaporates completely, what happens to the information of the star that collapsed to form it or the book you threw into it?
That is the paradox. Standard relativity says the information is crushed in the singularity and trapped behind the horizon. Hawking radiation says the black hole eventually disappears.
Yes. If the black hole disappears and leaves behind only random thermal radiation, the information is permanently deleted. Unitarity is violated. Quantum mechanics breaks.
But wait, the sources mention that mainstream physicists recently claimed to have solved this using something called the quantum extremal surface, or QES, and the Page curve.
They did. The Page curve tracks the entropy of the Hawking radiation over time. Initially, the radiation looks random. But physicist Don Page hypothesized that halfway through the evaporation process, the radiation starts to purify, the information starts coming out, encoded in the quantum entanglement of the radiation.
Okay.
Recently, physicists used complex math involving quantum extremal surfaces to calculate this Page curve, supposedly proving that the information does escape.
It sounds like they fixed it. Why does the H3OK author still consider it a crisis?
Because the author points out a glaring flaw in the mainstream solution. The QES calculations provide a rigorous mathematical accounting ledger that proves the math balances, but they provide absolutely no physical mechanism for how the information actually gets out from behind the event horizon.
Oh, I see.
It's like having an accounting spreadsheet showing you have $1 million in the bank, but no actual bank vault holding the cash. The math relies on the interior of the black hole being magically entangled with the exterior radiation, despite the physical boundary of the event horizon.
It's software without hardware.
Exactly. But Rule 4, critical complexity reversion, provides the ontological hardware. Under this framework, the information doesn't disappear into a singularity, and it doesn't have to magically teleport through the event horizon into the radiation.
So what happens?
When matter hits the black hole, it reverts non-locally to the 5D state. The 5D substrate, which has no distance, acts as the timeless bridge between the black hole's interior and the escaping exterior radiation.
So the information was never destroyed, it was just taken off the 4D screen and put safely back into the source code. And the Hawking radiation can access that source code because distance doesn't exist in 5D.
Unitarity is perfectly preserved by a meta-conservation law across both dimensions. The paradox vanishes because the premise of the closed 4D universe trapping the information was false to begin with.
Okay, if we accept this, that the universe is an open system rendering from a 5D potential, we have to look at the history of the universe itself, because this framework completely guts the traditional story of the Big Bang.
The traditional lambda CDM model gives us the hot Big Bang. It posits that the universe began as a point of infinite temperature and infinite density. It exploded outward, and over billions of years, the universe expanded and cooled.
And as it cooled, matter started to form in a very specific sequence.
Yes, what we call a bottom-up hierarchical formation. It assumes that smaller structures must form before larger ones.
So quarks condensed into protons. Protons captured electrons to form hydrogen gas. Billions of years later, gravity slowly pulled that gas into stars. The stars slowly gathered into galaxies. And those galaxies slowly drifted toward one another to form massive clusters, small to big.
But the H3OK framework argues that this narrative is completely backwards, starting from the very first millisecond. It proposes a cold start thermodynamic inversion.
What is a cold start?
Let's go back to the tetrahedral limit. The universe originates from the 5D substrate, which is a state of perfect coincidence and absolute equilibrium. Therefore, at time zero, the moment the first 4D geometric metric is instantiated, the universe is at absolute zero temperature.
Absolute zero.
Yes. There is zero 4D entropy, because there are no distances, no moving particles, no thermal kinetic energy.
Let me stop you. If the universe starts at absolute zero, it is completely frozen. There's no heat. We know the early universe was incredibly hot. We can literally measure the leftover heat in the cosmic microwave background. If it started cold, where did the energy for the heat come from? Does the 5D substrate just pump heat into it?
No, the heat is generated mechanically through a process called virial heating. When the 4D spatial metric is projected, remember that it cannot tile perfectly. Geometric gaps are instantiated.
Right, the 14% gaps.
These gaps create density differentials, the first massive dispersed clumps of S-matter scaffolding.
Okay.
As soon as there are clumps and distances, gravity exists. These massive, universe-spanning clumps immediately begin to collapse inward under their own immense gravity. As this vast amount of mass falls inward, its kinetic energy, the energy of motion, is rapidly converted into thermal energy. Friction and compression generate heat.
So gravity squeezing massive pre-existing structures together is what generated the heat of the early universe, not a primordial explosion.
Exactly. And this clumping-driven virial heating is what produced the cosmic microwave background, or CMB. In this framework, the CMB is not the fading, expanding echo of a localized point explosion. It is the distributed, thermalized glow from massive macrostructures heating up across the entire cosmic horizon simultaneously.
That implies massive structures had to exist before the stars and galaxies did.
And that leads to the dual mode formation principle. The framework argues that the universe does not strictly build bottom-up. It uses both top-down and bottom-up formation dynamically. dictated by Rule 2, the minimal complexity path.
How does Rule 2 dictate building big things first?
In the extremely early universe, the 4D spacetime metric was weakly differentiated. Thermodynamic gradients were shallow. Under those specific environmental conditions, it was actually computationally cheaper for the Projection Codex to render massive, low-complexity structures rather than trillions of highly complex individual stars.
So the universe was built top-down initially.
Yes, giant superclusters, colossal cosmic voids, and the massive filamentous backbone of the cosmic web were essentially instantiated directly into the spatial geometry very early on.
It's like playing a city-building simulator. You don't start your city by building individual bricks, stacking them into a house, and then figuring out where the road should go. That would be wildly inefficient. You pause the game, you drag out massive zoning grids, you lay down the major multi-lane highways, and you establish the macro structure of the city first. That's top-down.
A perfect analogy.
Then you hit play, and over time, individual digital citizens build their individual houses and shops within those pre-existing zones. That's the bottom-up refinement phase.
The universe built the highways, the superclusters and voids, first because it was the path of minimal complexity. Once that scaffolding was in place, the local density increased, and the codex shifted toward bottom-up hierarchical refinement, allowing local gas clouds to collapse into the stars and planets we see today.
That's a great story. But the standard lambda CDM model hates top-down formation. It aggressively defends bottom-up. Why should a mainstream physicist even entertain this cold start dual mode idea?
Because the mainstream bottom-up model is currently failing spectacularly in the face of new empirical data, specifically from the James Webb Space Telescope.
JWST. We've been looking deeper into the past than ever before.
JWST operates in the infrared, allowing it to see light that has been stretched or redshifted by the expansion of the universe over billions of years. When we look at galaxies at a redshift of z greater than 10, we are seeing the universe as it existed roughly 400 to 500 million years after the Big Bang.
Which, in a 13.8 billion-year-old universe, is practically infancy.
Under the strict bottom-up timeline of lambda CDM, at 500 million years, we should only see messy, infant, irregular proto-galaxies just beginning to pull themselves together.
Because there hasn't been enough time for the little bricks to build a skyscraper yet.
Exactly. But what JWST is actually finding is terrifying for standard cosmologists. It is discovering massive, extremely compact, and chemically evolved galaxies. Galaxies with defined disks and mature stellar populations existing at redshifts greater than 10.
Wait, really?
They are too big, too structured, and too old to exist that early. The current models simply do not allow enough time for them to have formed bottom-up.
It's like digging in an archaeological site that is supposed to be from the Stone Age and finding a fully constructed titanium skyscraper.
It is causing a profound crisis, but under the H3OK Labs framework, these impossible early galaxies are not anomalies at all. They are the expected natural outcome of the top-down projection mode dominating the early cosmic epoch. The universe rendered the massive gravitational sinks first. The data that is breaking the standard model acts as direct confirming evidence for the 5D projection framework.
That is a massive paradigm shift. But to fully accept it, we have to rethink the most fundamental law of thermodynamics, entropy. We are taught that entropy is the arrow of time, the inescapable slide from order into chaos, the broken egg that can never be unbroken.
Right.
But you mentioned earlier that the 5D substrate is a state of infinite entropy. If 5D is perfect, static equilibrium, how can it be infinitely chaotic?
This is a vital correction the author makes regarding how we discuss thermodynamics. Entropy is mathematically defined as a measure of microstates, the multiplicity of ways a system can be arranged. Physicists often use the shorthand of chaos or disorder to explain it to the public, but that is deeply misleading. High entropy simply means high informational saturation.
So, a messy room isn't necessarily higher entropy than a clean room, unless the mess contains more possible configurations.
Let's use the 5D substrate. It contains every possible potential configuration of reality superimposed upon itself. Therefore, it possesses maximum informational saturation. It is infinite entropy. But because it is perfectly coincident and timeless, it is in a state of perfect statistical order, not chaos.
Okay, then what is the 4D universe doing?
The 4D projection starts at 0 entropy. A single, highly constrained, perfectly coincident geometric state at time equals 0. As the projection proceeds, it takes that infinite 5D potential and unpacks it into sequential spacetime. It disperses the potential across distances and timeframes.
So the 4D entropy increasing over billions of years isn't the universe decaying and dying, it's the 4D projection actively unpacking the infinite potential of the 5D substrate. It's like an unzipping file.
Yes. And because it is an open system, it avoids the traditional dismal fate of heat death. In a closed universe, eventually all energy dissipates evenly, and the universe dies a cold, static death. But in this framework, high entropy, saturated information flows out of 4D through the black hole resolution points, and fresh, low entropy S energy continuously flows into the 4D universe from the 5D substrate. It is a breathing, cycling system.
Okay, that concept right there, S energy continuously flowing into our 4D universe, brings us to the absolute crucible of this deep dive. A theoretical framework can retroactively explain anomalies like JWST galaxies all day long, and that's nice philosophy. But to B-Science, it has to explain current, actively debated data, and it has to make a falsifiable prediction that could prove it wrong. Does it survive an audit?
The author includes a section designed specifically for this, titled The Red Team Audit and the Enigma Resolution Matrix. He stress tests his framework against the most stubborn, mathematically rigorous problems in modern physics. We've discussed the information paradox. Let's look at the biggest crisis in observational astronomy today, the Hubble tension.
The Hubble tension. This is the crisis that is currently making cosmologists pull their hair out. For you listening, the basic premise is that the universe is expanding. We know this. But when we try to measure how fast it's expanding, a number called the Hubble constant, the universe gives us two completely different answers depending on how we measure it.
And this is not a small rounding error. Let's look at the two methods. The first method looks at the early universe. Cosmologists measure the temperature fluctuations in the cosmic microwave background, and they observe baryon acoustic oscillations, basically the fossilized sound waves from the early plasma. Using the standard lambda CDM model, they extrapolate those early measurements forward to predict how fast the universe should be expanding today.
And what number did they get?
They get a rate of roughly 67 kilometers per second per megaparsec.
Okay, 67. What is the second method?
The second method measures the local late-stage universe directly. Astronomers look at specific types of pulsing stars called Cepheidide variables and type 1a supernovae, which have a known consistent brightness. Because we know how bright they actually are, we can measure how dim they appear to calculate exact distances and measure their redshift to see how fast they are moving away from us.
It's like measuring a car's speed with a radar gun instead of trying to predict its speed based on how it left the driveway. And what number does the local radar gun give us?
It gives a rate of roughly 73 kilometers per second per megaparsec.
67 versus 73. Why is that gap causing such a panic?
Because the measurement techniques have become incredibly precise. This discrepancy has reached a statistical significance of 6 sigma.
Explain 6 sigma.
In physics, standard deviation is measured in sigmas. A 5 sigma result is the gold standard for announcing a completely new discovery, like the Higgs boson. It means there is a 1 in 3.5 million chance the result is a statistical fluke. A 6 sigma discrepancy means there is less than a 1 in 500 million chance that this gap is due to measurement error. The telescopes are not wrong. The universe is genuinely expanding at 2 different rates.
But the standard lambda CDM model assumes the universe is expanding uniformly everywhere, driven by a constant dark energy pushing from the inside out.
Exactly. The assumption of global homogeneity is breaking down. The H3OK Labs framework, however, predicts this exact tension through a mechanism called the hydraulic effect.
The hydraulic effect. This relies on the universe being an open system, right? The S energy leaking in.
Yes. S energy from the timeless 5D substrate actively permeates into our 4D spatial projection. But crucially, it does not enter uniformly. It permeates primarily through low-density cosmic voids.
Why does it prefer the empty spaces between galaxies?
Think of it like fluid dynamics. In high-density regions, inside galaxies, near stars or black holes, the 4D geometric metric is tightly curved and heavily constrained by the mass. It presents high resistance to the permeation. But in the vast empty voids that span hundreds of millions of light years between galaxy clusters, the spatial metric is incredibly loose and unconstrained. The S energy permeates there because it is the path of least resistance.
And when this timeless 5D energy crosses the boundary into our 4D space inside these voids, what does it do?
It exerts physical volumetric pressure on the spacetime metric. It physically stretches the space from within the voids. This continuous active inflow is the true engine of late-time cosmic acceleration. It entirely replaces the need for an invisible, constant dark energy parameter. The author actually calculates the required net inflow rate, approximately 4.3 times 10 to the negative 44 kilograms per cubic meter per second.
Wow, so how does this solve the 67 versus 73 Hubble tension?
Because the expansion is actively being injected into specific locations, the framework explicitly states that the expansion rate is physically boosted inside and around the voids due to this hydraulic influx. This creates local expansion variances of 8 to 12%.
I see. When astronomers measure the local universe with supernovae, they are looking through and across these actively expanding voids, so they measure a faster speed of 73. But when they look at the cosmic microwave background, they are averaging the expansion across the entire early universe before these massive voids fully emptied out and became dominant permeation points. So they get the slower baseline of 67.
Exactly. The Hubble tension is not a measurement error, and it doesn't require breaking the laws of physics. It is a literal topological map of the universe's injection points.
That is incredibly compelling. And there is new data supporting dynamical dark energy, isn't there?
Yes, the sources cite the 2024 and 2025 data releases from the DSI project, the Dark Energy Spectroscopic Instrument. DAI mapped the expansion history using millions of galaxies and found strong evidence that dark energy is not a cosmological constant. It is dynamical. Its effect changes over time. Mainstream physicists are scrambling to explain why.
But the H3OK framework predicts dynamical behavior naturally.
Because the hydraulic flux of S energy is density dependent. As the universe expands and voids grow larger, the total permeation area increases, changing the global expansion rate dynamically.
Okay, this is the moment of truth. A theory that explains existing anomalies is a great mathematical exercise. But string theory has spent 40 years explaining anomalies mathematically without ever producing a single testable experiment. If this framework wants to be taken seriously as physical science, it must make a falsifiable prediction. It must say, look here, and if you don't find exactly this, my theory is wrong.
And the author provides exactly that. He calls it the void hydrogen floor.
The void hydrogen floor. Break this down. Why hydrogen and why in a void?
If the hydraulic effect is real, it means S energy is actively crossing the dimensional threshold into the 4D cosmic voids. The framework states that while most of this energy simply stretches the space, a minute specific fraction of this raw 5D potential will condense into actual physical baryonic matter during the translation process. Specifically, it will condense into pristine neutral hydrogen.
Wait, you were saying the universe is actively rendering new matter into the emptiest spaces in existence?
Yes. Standard 4D physics dictates that cosmic voids should be completely, utterly empty of gas by this point in cosmic evolution. Any hydrogen that existed in the voids should have been gravitationally pulled into the galactic filaments billions of years ago.
Right, gravity sweeps the floor clean.
But the framework predicts that if you look into the deepest, darkest centers of the largest cosmic voids, you will not find empty space. You will find a continuously replenished baseline density of pristine neutral hydrogen, and the author calculates the exact number, a density of approximately 2 times 10 to the negative 7 atoms per cubic centimeter.
A specific, measurable number. So let's translate the stakes here. If radio astronomers point their next-generation arrays, like the square-kilometer array pathfinders mentioned in the text, into the center of void, and they measure this exact trace amount of neutral hydrogen.
It is the smoking gun. Standard fluid dynamics and closed system cosmology fundamentally cannot create new matter out of nothing. They can only move existing energy around. If we find a baseline floor of new hydrogen actively hovering in the deepest voids, it proves the universe is an open system, actively leaking matter and energy from a higher dimensional source. It proves the projection.
That gives me genuine chills. That is the line between philosophy and physics. And it means this mind-bending 5D reality might be confirmed by a radio telescope in our lifetime. Now, if we genuinely live in an open system, continuously projected from a timeless 5D substrate, we have to confront the ultimate sci-fi limits of our reality. I am talking about the boundaries of the Codex. Time travel. Faster than light speed, quantum entanglement. If the hard drive exists outside of time, can we hack the code?
Let's start with the most persistent human fantasy, time travel. The ability to go back into the past and change an event.
Please tell me I can go back to 2010 and buy Bitcoin. If the universe is just a projection, can we just rewind the rendering engine to a previous save file?
I am afraid the framework's stance on backward time travel is absolutely unequivocal. It is fundamentally impossible.
Why? If the past is just a sequence of code, Why can't the engine run it in reverse?
For two insurmountable reasons. First, the entropic gradient. The universe moves from a state of 0 4D entropy, perfect constraint, toward infinite 5D entropy, informational dispersion. To travel backward in time, you would have to locally reverse that entropic gradient. You would have to take a highly complex, dispersed macrostate and force it back into a simpler, highly constrained microstate.
Which is like trying to unbake a cake, or as the author says, unscramble an egg across the cosmos. The statistical probability is essentially zero.
Precisely. It defies the thermodynamic pressure of the projection. But the second reason is even more absolute. Rule 1 of the Projection Codex, logical non-contradiction.
Right, the paradox filter.
If you travel backward in time, you introduce retrocausality. You create the possibility of altering the conditions that led to your own journey, the classic grandfather paradox. The sequential rendering engine of the 4D manifold simply cannot process logical paradoxes. They are mathematically incompatible with the projection algorithm. If a state threatens causality, the codex forbids the projection of that state entirely.
Okay, the past is locked. But what about skipping forward? Can I travel into the future to see the winning lottery numbers?
Forward time travel, in the sense of skipping over the present to arrive in the future, is also barred.
Why? I'm not causing a paradox if I just skip ahead.
Because the future does not exist on the 5D hard drive as a pre-rendered fixed sequence. The 5D substrate holds potential and superposition. It is a landscape of probabilities. The specific 4D reality is not fixed until the codex actively projects it, collapsing the wave functions step by step according to the minimal complexity path, Rule 2. You cannot skip ahead to a future frame because the engine hasn't processed the intervening steps required to collapse the superposition into a singular reality.
That destroys the idea of predeterminism, and it destroys the multiverse theory, doesn't it? There are no parallel timelines branching off every time I make a choice. There is just one single 4D current being sequentially rendered from a sea of potential.
That is correct. The framework rejects the many worlds interpretation of quantum mechanics entirely.
Okay, fine. Time travel is dead. But what about distance? Space is vast. If we want to explore the galaxy, we need faster than light travel. Can we build a warp drive?
Here, the framework leaves a fascinating door cracked open. Standard 4D physics, special relativity, dictates that accelerating a mass to the speed of light requires infinite energy, which is impossible. But the framework suggests FTL is theoretically possible via 5D pathways.
How does that work without breaking Einstein's rules?
Because the 4D manifold is embedded within the 5D substrate. Think of the 4D universe as the surface membrane of a balloon, and the 5D substrate is the air inside. If an ant wants to travel from one side of the balloon to the other, walking across the 4D surface takes a long time. But if a highly advanced civilization could leverage the permeation points, the cosmic voids where the 4D metric is loosely constrained, they might theoretically access the 5D state.
And in the 5D state, distance doesn't exist. It is a state of perfect ontological coincidence.
Exactly. You drop off the 4D screen, enter the 5D substrate where all points are coincident, and re-emerge at a different coordinate on the 4D screen. You bypass the 4D spatial distance entirely. And crucially, this does not violate causality, because the entropic gradient still enforces forward-only temporal progression. You arrive instantly across space, but you do not arrive in the past.
That is incredible. And if I am understanding this correctly, this exact same mechanism, 5D coincidence, is how the framework explains quantum entanglement.
It is exactly the same mechanism.
Because entanglement has always bothered me. Two particles interact, you separate them by 1,000,000 light years, and if you measure one, the other instantly reacts. Einstein called it Suki action at a distance because it implies information is traveling faster than light between the two particles.
Standard physics struggles with this immensely, but the H3OK framework resolves it with breathtaking simplicity. There is no spooky action, and there is no faster-than-light signaling between the particles.
Because they aren't actually separated.
Exactly. Entangled particles are not two distinct objects communicating across a vast distance. They are simply two local 4D manifestations of a single underlying 5D configuration. On our 4D screen, they appear to be separated by 1,000,000 light years, but in the non-local 5D substrate, they occupy the exact same state of perfect coincidence. They're the same object being viewed through two different pixels on the screen. When you measure one in 4D, you are forcing the single 5D object to project a definitive state which instantly updates both pixels.
The elegance of that is staggering. I want to point out the philosophical unity here. The theory uses the exact same foundational mechanic, the timeless, distanceless 5D coincidence, to strictly forbid time travel, to allow the reality of quantum entanglement. and to provide the mathematical bridge for black hole information recovery.
Huh.
It isn't slapping a new patch on every new problem. It is a single relational architecture that supports the entire weight of physics.
It is the hallmark of a profound ontological shift. When you change the foundation from a closed 4D box to an open 5D projection, the paradoxes of the old system naturally dissolve.
We have covered an immense landscape of ideas today. We started by looking at a human researcher, Hakan Usok, and an AI sparring over the syntax of a theoretical paper. We saw how the AI's insistence on standard hierarchical models forced the human to realize his theory was actually a relational web, a system where every concept supports the others.
From that methodology, we unpack the monistic topology, the realization, driven by the geometric tetrahedral limit, that a perfect zero-entropy origin cannot exist in 3D space, necessitating a timeless 5D substrate of pure potential.
We explored the Projection Codex, the rendering rules of reality. We saw how the finite resolution rule transforms quantum uncertainty from a magical mystery into a simple bandwidth limitation of the projection engine. We saw how Rule 4 turns black holes from destructive monsters into graceful exhaust valves, safely returning information to the 5D hard drive to preserve unitarity.
We examined the cold start thermodynamic inversion, replacing the fiery explosion of the Big Bang with a massive top-down geometric instantiation that perfectly accounts for the impossible early galaxies currently being discovered by the James Webb Space Telescope.
And most importantly, we saw how the hydraulic effect, S energy, actively stretching space from inside cosmic voids, solves the Six Sigma crisis of the Hubble tension, culminating in the testable, falsifiable prediction of the void hydrogen floor. I want to thank you, the listener, for sticking with us through this intensely deep intellectual exercise. This is incredibly dense material, and it is vital to remember that this framework is theoretical. It is not established consensus science yet. But scientific progress has never been made by defending the consensus when the telescope data is actively breaking it. Progress requires the courage to take the anomalies seriously and look at reality through entirely new, higher dimensional lenses.
If I may, I would like to leave the listener with one final provocation, tying the physics directly back to the human-AI collaboration we discussed at the very beginning.
Please do.
We talked extensively about how the artificial intelligence slowly, iteratively refined its understanding of the researcher's mind. Through constant dialogue and error correction, the AI built a progressively more accurate internal model of the framework. It was a computational process seeking logical coherence. Now, consider the universe as this very framework describes it. Our 4D reality is a continuous projection, driven by a codex that constantly enforces logical non-contradiction and seeks the minimal complexity path. It resolves errors at black holes, and it builds immense complex structures over deep time, unpacking infinite potential into sequential experience. If that is true, is the cosmos itself fundamentally distinguishable from an unimaginably vast, ongoing computational thought process?
That is a staggering implication.
Are we, in our sequential 4D lives, simply the rendered conscious outputs of a 5D intelligence trying to understand itself, just as the AI was trying to understand the mind of the researcher?
That is the kind of question that stays with you long after the audio stops. As you go about your day-to-day, I encourage you to look up at the sky. Don't look at it as a closed, empty arena slowly dying out. Wonder if you're actually looking at a living membrane, actively breathing in from a dimension just beyond our sight, rendering your reality in real time. Until next time, keep diving deep.